Hello guys, let us solve this question from the idea of conservative forces and scalar potential. Here there is a force field given. The first question is to show that the force field is conservative, and the second question is to find the work done when a particle is moved from one point to another point. So let us consider the given force. F is equal to 2xy plus z square I cap plus x square j cap plus 2xz k cap. So in this given function, the coefficient of I cap is the x component of the force, and this is the y component of the force, and this is the z component of the force. Now, how do we check whether the given function is a conservative function or not, conservative force or not? To find that, we will find the curl of the function del cross f. Now, if the curl of a function is 0, then that implies that the force function f will be a conservative one. So all we have to do is to find the curl of the given function. So let us do that. Del cross f will be equal to I cap, j cap, k cap. So here I am using the determinant method to find the curl. So I wrote first row I cap, j cap, k cap. Second row dou by dou x, dou by dou y, and dou by dou z. And third row the component of the force, that is the x component, is 2xy plus z square. Y component is x square and the z component is 2xz. Now let us find the determinant. The I component of the determinant will be dou by dou y of 2xz minus dou by dou z of x square. Similarly, the y component will be dou by dou x of 2xz minus dou by dou z of 2xy plus z square. And the k component will be dou by dou x of x square minus dou by dou y of 2xy plus z square. So I'm directly writing the result. So here the I component will be I cap into dou by dou y of 2xz will be 0 minus dou by dou z of x square will be also 0 minus j cap into dou by dou x of 2xz, that is 2z, minus dou by dou z of 2xy plus z square, that will again give you 2z because 2xy has no z component, like z variable in that. So only the derivative of z square will come, that is 2z. Now the k component plus dou by dou x of x square, that is k cap into 2x minus dou by dou y of 2xy plus z square will be again 2x. So what we can see is the coefficients of I cap, j cap, k cap all are 0. So del cross f will be 0, or the force is a conservative force. So this implies that f is conservative. So if the force is conservative, then we know it can be derived, it is the gradient of a scalar potential. Whenever the force is a conservative force, it can be derived from a scalar potential using the idea of gradient. So that means there exists a scalar function phi such that gradient of the scalar function is equal to our conservative force. So how do we find this phi? So to find the phi, we know fx is equal to dou by dou x of phi, fy is equal to dou by dou y of phi, and fz is equal to dou by dou z of phi. So that means phi will be equal to integral of fx dx plus a function g of, we are integrating with respect to x, so the g will be a function, g can be a function of y comma z. Similarly, phi can be also written as integral of fy dy plus another g dash of x comma z. Similarly, phi can be written as integral of f z dz plus g double dash another function of y comma z. So this is the method we are going to use to find the phi function. Once we have the phi function, then we can find the work done. So according to the first formula, phi will be equal to integral what is fx? Fx is 2xy plus z square into dx. So when we integrate, we will get x square y plus xz square plus some function g of y comma z. So in the same way, we can do find the phi value using the fy component, and the fy component is x square. So it is integral x square dx, sorry, x square dy. That will give us x square y plus g dash of x comma z. Now again using the last formula, again we can find phi is equal to integral 2x, what was the function, 2xz. So 2xz dz, when we integrate we will get xz square plus g double dash of y comma z. So we have to compare the three phi functions we got here, and we have to collect the common terms. Then the phi, the scalar function phi of x comma y comma z will be equal to, let us see the common terms. So here x square y is there, x square y is there. So we have to take this x square y plus the another function is xz square. Here also xz square is there. So xz square plus there can be a constant. There is no other function we are getting here. So we can write plus a constant c. That constant will be a number. It is not a function of x, y, z, but it can be a number. Okay, so we got our phi function. Now the work done will be equal to change in phi. Okay, so change in phi. So this is our phi function. So x square y plus xz square plus c. So it changes from where to where. We have to see the points. So in the question it is given that it goes from 0, 1, 2 to 5 to 7. So the upper limit will be 5 comma 2 comma 7. In the lower limit is 0 comma 1 comma 2. Okay. So first we will substitute the upper limit, that is x square, that is 5 square, that is 25, into the value of y is 2 plus xz square. So 5 into z square, that is 7 square, that is 49, plus c minus the lower limit, because x is common for the first two terms and the value of x is 0 for the initial point. The first two terms will go to 0, so minus c. So c cancels, and what we have is 25 into 2, that is 50, plus 49 into 5, that will be 24. Right, so 245, right? So 50 plus 245 will be 295, and answer will be in joules because the force is given in Newton and distance in meter. So work done is equal to change in potential, scalar potential, that is 295 joules. So that is the solution for the given question.